Before we get started, I have a quick favor. I've been self-funding the Finding Genius podcast for 5 years now. I've done over 3,000 episodes. And as you can see on YouTube, we're up over 1 million views on the channel, which is fantastic. The next thing I really want to push on is to get up to 10,000 subscribers. Because once we do, we'll be able to put a donate button and we'll be able to solicit donations to help keep the podcast running and to also get the Finding Genius Foundation moving along. We have a big project studying anxiety, depression, and PTSD and working on a product to help people overcome these problems because I've seen them explode recently after the last 2 years of the whole virus situation. So if you would, please subscribe to the podcast. That would help us tremendously. Give us a thumbs up and check in the description for Buy Me a Coffee. It's about $5. If you could buy me a coffee, I'd really appreciate it. It would help keep the channel going, and I love coffee. Thank you.
Forget frequently asked questions,
common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
go above and beyond.
They become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
with Richard Jacobs.
Before we begin, a note from our sponsor. I'm Richard Jacobs, Executive Director of the nonprofit Finding Genius Foundation and host of the Finding Genius Podcast. In late 2016, I was rear-ended at 65 miles an hour by a truck on the highway, which sent me off-road into a ditch. The impact of the collision gave me a concussion and other injuries. At the hospital, a CT scan showed that I had thyroid nodules, which turned out to be cancer. It was then, when I had a biopsy in my neck, that I realized even if I was a millionaire, I wouldn't want a second or a third biopsy due to the pain and the invasiveness of it. And appointments at that time for thyroid experts were 3 to 6 months out. And I was worried about dying now, even if that was irrational. So because of this, I've decided to raise money to conduct a literature review on steroids, on the causes of anxiety and depression, a condition that affects well over 50 million people in the United States and hundreds of millions worldwide. Our goal is to create a codex, a guide that reveals all possible treatments for anxiety and depression for people that live with the condition, or for loved ones that have it, as my wife and my son do. To find out more about our fundraiser, visit findinggeniusfoundation.org and click on Current Initiatives. And now, to our guest.
Hello, this is Richard Jacobs with the Finding Genius Podcast, now part of the Finding Genius Foundation. Today I have Hans Plugge. He's a principal at Safer Chemical Analytics LLC. We're going to talk about the toxicological work that he does. So, Hans, thanks for coming.
Thank you for having me.
Yeah, if you would, tell me a bit about your background and then the work that you do today.
I have about 40 years of experience as an environmental consultant. I have a bachelor's degree from the University of Amsterdam in Amsterdam, the Netherlands, in chemistry, a master's degree in environmental chemistry from the University of Guelph in Guelph, Ontario, Canada, and a master's degree in toxicology from the Harvard School of Public Health. And I've been doing consulting since 1979, and basically at present I went independent again July of last year. Basically most of what I've been doing right now is working on sustainability of environmental chemicals as well as some specialty consulting for chemical firms.
Okay. Hey, you sound like you're a New Yorker that has a Dutch name.
Yes, except I'm a Dutchman who came here 40 years ago and lost his Dutch accent. So
I understand. Well, very good. So the work you're doing today, the consulting work, what does that look like? Like what's an example of a typical job you take?
Basically, one of the things we're doing right now is helping a manufacturer of household goods, including furniture, in Denmark entering the United States market and basically helping her, in this case, to transition her inventory to U.S. standards so as to make it acceptable under a number of regulations in the United States. And that's sort of an outlier. Most of the other things I do relate to the toxicology of chemicals in the environment and in the workplace. And one of the things I just wrote is a paper on sustainability metric where you can measure how sustainable the chemicals are in the chemical inventory of chemical manufacturers or formulators or whatever other chemical enterprise you're looking at.
I don't know if you want to comment on it, but over the past few years, there's been a lot more cleaning. I mean, that's what people call it. With like quaternary ammonium compounds. Do you deal at least with any of the occupational hazards from that kind of material, or is that not your area?
It's not something I've worked on directly. I've sort of been on the periphery. I've listened to presentations and things like that. A lot of the things I work on, I talk about risk and hazard. And, one of the things is some things are inherently hazardous, but if you don't have any exposure to it or very limited exposure to it, it's not very risky. I think the classic example I always use is vinegar. Vinegar consists of acetic acid, which is a really nasty chemical, burns, things like that. However, when you eat vinegar in your pickles or anything like that, most people don't have a problem with that. So you have to make sure that you know your hazard and you know your exposure, because that's the only way you can know your risk.
Okay, that makes sense. So when you talk about sustainability of various chemicals in the environment, what does that mean? Like how long they last in the environment, or how do you express that?
Yeah, there are a lot of different ways to measure sustainability. I'm looking specifically at the health and environmental effects directly of the chemicals, but you really got to do some systems thinking where you look at how something is manufactured, how it affects the environment, how it's disposed of, how it's used in households, et cetera. The entire, what they call cradle to cradle of starting a product and then working all the way through its disposal and seeing what kind of sustainable impacts it has along the line. And some of those are very surprising and not ones that people think of. So,
any good examples come to mind?
Yeah, I have a really good example. Plastic shopping bags. The people really get upset about disposal, and justifiably so. People throw their plastic bags. They end up everywhere. They end up in the trash. They end up blowing around. It's not very pretty. However, the environmental impact of a plastic bag versus a paper bag is made using rather harsh chemicals under incredible conditions with a lot of energy use, so that the actual life cycle impact of a paper bag is about 5 times as high as that of a plastic bag, even though disposal of a paper bag is not a problem. But you have to look again at the whole beginning, all the way back to where you started, from a raw material to where you end up with a finished product and disposal.
Yeah, it sounds like it makes it tough in these debates to really see what you're after, I guess.
Right.
You want to optimize something. Yeah.
Right. People focus on one aspect, and, you got to let them sort of look and see what other aspects you have to think about. And, it's the same thing as that, your reusable shopping bag. Some of them are, a woven plastic of some kind, and others are cotton. Woven plastic one pays back for itself really fast, about 15 uses, and you're economically and environmentally friendlier than your disposable plastic shopping bag. But if you then go to what people consider to be environmentally friendly, which is a cotton bag, it takes about 10 to 12 times as long for the payback and environmental cost on a cotton bag. You have to use it about 200 times before the impact drops below that of 200 disposable plastic bags.
Wow, that's a huge difference.
Yeah. And again, cotton is, it's a very disposable item. You can recycle it, but making cotton from raw cotton and dyeing it and washing it and printing on it is a very different impact, again, on the front end, rather than looking at the disposal end, which is what everybody cares about, because they're not a disposable bag. I reuse it. How can it be bad? So a lot of people prefer cotton bags, but don't think of the fact that 200 trips to the grocery stores, it may start wearing out. So,
before we continue, I've been personally funding the Finding Genius podcast for 4.5 years now, which has led to 2,700 plus interviews of clinicians, researchers, scientists, CEOs, and other amazing people who are working to advance science and improve our lives and our world. Even though this podcast gets 100,000 plus downloads a month, we need your help to reach hundreds of thousands more worldwide. Please visit findinggeniuspodcast.com and click on Support Us. We have 3 levels of membership from $10 to $49 a month, including perks such as the ability to see ahead in our interview calendar and ask questions of upcoming guests, transcripts of podcasts you're interested in, the ability to request specific topics or guests, and more. Visit findinggeniuspodcast.com and click Support Us today. Now, back to the show.
Let's say if you remember it, how long does it take you to go to the grocery store that many times, et cetera? If someone goes once a week, that could be 4 years, and they had to take the bag every time, in order to just break even.
Yes.
Crazy. So do you advise policymakers, and does any of them actually listen to you?
I go to conferences with policymakers, and one of the ones that we go to a lot is the American Chemical Society's Green Chemistry Conference, which I've been at for I think 6 or 7 years now. And one of the things there, it's a nice thing, is that there's both people from government, industry, and independents like myself and academia. So there's 4 different groups of people that all get together and talk about policy and listen to people's presentations. So there is a fair bit of fertilization, if you want to call it that, of ideas between the different branches. I have not in the last 10 years, I've done any direct government contracting work. I used to in the past work directly on government contracts and write policy and things like that.
Well, it just seems tough because, there's messages that get put out to the public and the public thinks, X, Y, or Z, and that may not put things in the right direction. But yet I would guess the pressure from wanting to appear green or appear sustainable or do this or that, shapes policy tremendously. So have you seen that, things are actually shaped in the right way scientifically where minimal inputs are focused on, or is it other focuses that don't help?
Well, scientists generally, just like engineers and lawyers, don't do a great job of communicating their own knowledge to members of the general public, if you want to call it, people who are not experts. So one of the things we got to do is basically do a better job of explaining things, and at the same time also work on communicating it in straightforward language and not talk about things like probabilities without explaining what a probability is, putting it in a common sense example where people actually can understand it. The other thing is industry. Some industries are extremely tuned in to environmental sustainability. Like the clothing industry is really setting up a big example. Not everybody in the clothing industry does it, but as a generic rule, the clothing industry is way ahead of some of the other industries as far as their sustainability impact, and actually tries very hard to come up with some certifications. Other people get certifications, and there's a concern that especially for instance for sustainable investing, there's a lot of concerns regarding how these certifications actually apply to particular companies. So you get the problem of greenwashing, which is basically making people look a lot greener than they really are.
So in the clothing industry, what are some of the things that they're doing to actually, reduce the inputs, reduce the outputs? Make it greener, as people would say.
Right. It's a cradle to cradle effort, starting with making greener cotton, using less water and chemicals to process it, using sustainable dyes so that basically they don't end up being contaminants in the environment, using less dye to make the same product by being a little better at processing things, and at the other end, making sure that your clothing is not becoming a disposable item, but actually can be used for an extended period of time by whoever buys it. And in some cases, you can recycle it for somebody else to wear it.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
Yeah, no, that's cool. Are there any other examples that, surprise the heck out of you or really irk you, that they're backwards, that, the wrong thing is prioritized? Anything comes to mind?
Yeah, I think the one thing is that people really focus on hazards. And, except maybe for water, although even water, you can come up with some hazards. Most things are hazardous in large enough concentrations. Some things are hazardous in really small concentrations, which is a problem. Those are problem chemicals. We need to get rid of those. But your average chemical, even if it has a hazard, is not used in quantities that expose people to concentrations that would cause a risk. And I think that hazard versus risk discussion needs to be had in more plain language.
What about effects like bioaccumulation, or again, accumulation over time of chemicals in your fat tissues or other reservoirs in the body?
Right.
What have you
And
studied there?
yeah, some chemicals do accumulate. Most of the chemicals that accumulate have been gotten rid of in commerce, whether through regulation or self-regulation, where people, have decided that this is not the best use of the economy to provide things like, polychlorinated biphenyls would be a great example that were, seems like a cat's meow in the 50s and 60s. And then throughout the 70s and 80s, people realized there were too many health effects, and industry got regulated and basically told you can't use this particular chemical anymore. So they have more or less disappeared. But even now, you can still find PCBs in fat tissue, in people and animals, in dough in much decreased concentrations than they were in the 70s and 80s.
Huh. Do you ever get into body burden calculations for the average person to evaluate what's inside them, or?
Yeah, you can. You get into some really weird things. Oh, here's a good example. Formaldehyde. It was a big thing, and people are very uptight about it's a carcinogen, which there's still a fair amount of scientific discussion on which country you live in, what is regulated as. But one of the things is we naturally have a very large quantity, well, relatively speaking, large quantity of formaldehyde in our bodies. As a matter of fact, we couldn't live if we didn't have formaldehyde, because it's one of the things that is what's called in the one carbon cycle and allows us to make some of our chemicals that we need to live. At the same time, from an exposure point of view, what do you take in the way of formaldehyde? A lot of your green vegetables have a measurable quantity of formaldehyde in them, which you eat on a daily basis. And you wouldn't say no to an organic pear just because it has formaldehyde in it.
Huh. Interesting. So I guess the dose makes the poison, but what's the other learnings that you've gotten from the things you've observed?
Well, one of the things you learn is that is the question. First of all, just because it's a so-called established fact doesn't mean that it really is true. You need to look at, critically look at the things, and again, look at the whole picture, not just focus on one thing, as in formaldehyde is bad for you, which would be the one thing that you can, people would pull off the internet and, start making larger concerns about. And then basically, once you've done the critical thinking, again, what I said earlier, you have to be able to communicate it. It's not good enough that you make a judgment that this is not a concern. You have to communicate to people why it's not a concern.
Do you have any examples of, I don't know, like what you feel was your most important project or your most memorable one that would make a good story for listeners?
This goes back a long time, back in the early 80s. And as I said, that's a long time. I worked on some of the Superfund sites around Northeast, and one of them was in Rhode Island. We won't mention names, but everybody who hears this will know which one it is if they've been working on it. And basically, the things that nobody else wanted, legally or illegally, were sent to this particular cranberry bog, where they built a big dike down the middle of the bog and just threw everything in barrels off the back of the truck. And that was considered illegal hazardous waste disposal even back then. Till one day lightning hit it and the whole thing went up in flames and basically burned for several days with smokes visible for 20, 30, 40 miles. And one of their covers was they had put a pig farm in the front of it. So all the pigs got high in the solvents. And when the cops and the firemen arrived, things got a little out of hand with pigs ramming everybody and every vehicle in sight. The stories in the newspaper stories were just wonderful to hear. Not the great environmental example, but, it's a sort of a story that sticks in your brain forever about what can happen if you do things illegally.
Yeah, that's weird. So what do you consider some of the most misunderstood, objects in use, meaning there's pressure for us to use one thing, but really maybe another form of that object would be more beneficial. Like when you mentioned, plastic versus cotton bags. Is there any other good examples that come to mind that there's a big misunderstanding about?
Yeah, there's a lot of, there's a whole branch of, I don't know, science is, I don't know which side it is. It's a conglomerate of a lot of different science called alternatives assessment, where people, once you identify something that is risky, both hazardous and exposure-wise a problem, then you got to come up with an alternative. And the first rule is that whatever alternative you come on has to be somewhat more or less the same efficacy. In other words, just as good at its job as what you replace it with, because there's no point in, getting something 10 times less toxic if you have to use 10 times as much. And you're back in the same boat where you started off with. And you have to do a very detailed, good job at it to make sure that your alternatives are indeed better. A lot of things that were replaced in the last 20 years, people replaced them with something that didn't have any data under the assumption that no data was good data. And that was basically proven wrong in the next 10 or 15 years. And we're back to square one, having to come up with a replacement for the replacement. And that's the sort of thing that I think people don't think enough about, that it's very easy to say that something is bad, but as a society, we've gotten used to having product X around, and when we have to replace it with something new, it's going to take 5 or 10 years to come up with something that's new, chemically and toxicologically characterized, and then economically feasible and marketed and actually get into the marketplace. It's not something you can do at the drop of a hat.
Are there any items out there right now that are particular candidates to this that about that really irk you?
No, there's some chemicals that are on the replacement list, like bisphenol A has a lot of data, a lot of lousy data showing effects, a lot of discussion that is not very good. And the problem there is that most of the hazards are at very high concentrations, and you just can't get that high concentration in somebody's body. Some of the replacements that have been suggested in the past turned out to be worse than bisphenol A, BPA. So basically, that had to be abandoned. And I don't think we're working on replacements, but I don't think we've gotten to a perfect replacement yet.
But it sounds like there may not even be a need for a replacement, possibly, right?
It needs to be characterized further, and again, communicated and looked at in detail. And the more people look at it in detail, the less the data indicate that there's a true risk. The hazard is still there, but even that, a lot of the detailed studies are finding less hazard than what people assumed there would be to find. Then there's a lot of scientific discussion over who did the research, how good the research is, and who's looking at it and who's interpreting it. Is it academia versus government? Is it public interest groups versus government? There's a lot of different interpretations of the same data. And that's confusing to the public also, because if one scientist cries that, this is a problem and 100 other ones say it's not a problem, everybody listens to the one guy.
Interesting. For the layperson, do you have any advice for them? I don't know, your friends, family, people you care about, do you tell them, hey, don't use that, use this, or avoid this? Any hints for people to help them?
Yeah, the classic, a recent example was that some of my nephews had rented a house or apartment, I can't remember, it's a house, I think, which had measurable lead concentrations in it. And along came the grandniece, and basically it was time to do something, and basically we found that it wasn't a very healthy environment. So when he bought a new house, he checked it out thoroughly, and the impact from the lead was diminished. And this is a problem because depending on where you live in the country, you either have an old or a new housing stock, and if you have anything before the 70s, you're likely to find, if you test, some lead in the paint and things like that. So that's one example. The other thing is it's not as much of a problem anymore, but when you're stripping furniture, use a green, water-based stripper, not a heavy-duty chemical solvent-based one. Most of those have been taken off the market, so you can't even get them anymore. But 10 years ago, that was a real problem.
What about in terms of people cleaning their houses or their businesses? Any suggestions there?
It depends on, most of the cleaning agents have been designated as safer chemicals by US EPA. There's a lot, if you look at your bottles, it says safer chemical designation. It's a label that's run by US Environmental Protection Agency. Those are basically cleaned. One of the problems with them is they require a lot more to clean than some of the older formulations. So things don't get quite as clean if you're really faced with a really cruddy situation. But for regular cleaning, they're just fine, and it does cut down the possibility of skin irritation or eye damage as a result of accidentally spraying it into your eyes or anything like that.
Are there any chemicals in use by regular people today that you think they really should consider avoiding? Some of the real bad ones, or does it get you in trouble to say it? If
no, it's not. It doesn't get me in trouble for saying it. I think in the last 10 years, especially, a lot of the stuff that was dangerous, like I told the paint strippers, has been either voluntary or involuntarily, recalled from the market. Things that contain methylene chloride strippers are done as a household item. You used to be able to sell it at the big box stores, and you can't get it anymore, even if you wanted to. There's still some used for commercial uses, but even that is decreasing. So, but the alternative is that you have to strip paint off somehow for, applications, whether it's necessary for furniture, that's a whole different story. But there are other applications where you do need to take paint off in a relatively easy way, because sanding it causes sanding dust, which has got some issues with it as well. So you have to weigh your alternatives, whether you're going to sand the living daylights out of a piece of wood to get the paint off, or whether you use a water-based chemical stripper, and just take your time.
So what I don't know, what projects are you working on, or which ones do you want to work on? Is there any particular chemical use out there that you would love to work on, or that you are working on that's interesting to you?
Yeah, most of what I do is private clients, so can't talk about it except in really broad terms. But yes, the sustainability metric that we published this spring, I'd like to see some applications of that coming through, and there are people interested. It's not something that's being done at this point, but it's just a question again. People are barely getting used to looking at ESG measures like, greenhouse gases, and we still have a hard time measuring those and coming up with reasonable numbers for those. That to look at chemical impact is a whole, notch above that. So it's going to take some time to get people comfortable with it. And again, most people who are in the sustainability field aren't chemists. So to them, chemistry is sort of a black box. And that's something that shouldn't be happening. The other thing that I think should be clear to people at this point, that, and I don't think a lot of people outside the industry know, is that toxicology used to involve a lot of animal testing, large quantities of animals, lots of chemicals. That's disappearing. So basically, in a lot of countries, there is a regulatory push to no longer submit animal data, but instead do in vitro, which means in a test tube, or in silico computational approaches to the same thing, where animals don't have to be tested. Skin sensitization is a classic example. You used to have to test that in a large number of animals to make sure that people wouldn't get skin reactions. And there are a lot of test tube tests, so to speak, that are out there now that do a better job than the animal data. So that's a win-win. We don't using animal data, plus we come up with a better result.
Yeah, it's very good. Do you think they we're headed in the right direction? The analyses and the weighing of factors is going the right way, or do you feel like it's not?
I think a lot of the problems we've had in the past is we've looked at something in an animal and it doesn't give the same effect in humans as it does in the animal. And the same thing the pharmaceutical industry suffers with this through. They do all the testing in animals, and it shows it has absolutely no liver effects, and they run the first limited test in humans, and liver problems pop up right away, and drug is pulled from the market, and that's pre-market approval. So a lot of what's happening is even they are doing test tubes and basically going to computational approaches. And there is something that's coming out that'd be very interesting. There are these tiny little microfluidics, they're basically the size of a microscope slide, where you can actually put a chemical in and have some cells present, human cells present, that will metabolize your chemical and actually show an effect directly in the cells without you having to do a whole animal testing. On top of it, you don't have to extrapolate from the animal to the human. You're actually using human data to protect humans. And that's called the human on a chip. And I think in the next decade, you're going to see that that's going to get more and more important. And in 10 years from now, hopefully, that's going to be our main focus of testing.
Yeah, I had spoken to, I don't remember their name, it's been a long time, but I spoke to a scientist that was making these various organoids. And what was interesting is they were testing one drug that, to see if it had a heart toxicity, and it didn't. But then when they hooked up, let's say, a heart organoid to a kidney organoid, they saw like this chemical went through the kidney, and then it was processed and changed, and then it became toxic to the heart.
Mm-hmm.
But they wouldn't have seen that unless they linked together several, pseudo organ systems. So,
yes.
I mean, do you see the same type of necessity for this human on a chip project type thing?
Yes, and the human on a chip project, the question is just miniaturization more than anything else. There are some experimental test systems in being where basically people do things like run a chemical through the liver, which is the major place besides the kidneys where things are transformed into other chemicals, metabolites, and then running whatever blood alternative comes out of the kidney, running that through brain cells and seeing, for instance, if they get any brain effects, neural effects directly, either from the chemical directly or after it's passed through the liver. So that's the sort of thing where, people are really working on, and I think the stuff is not quite there, ready for prime time, but it should be ready in the next, definitely in the next 5 years, and I think in wide use in 10 years.
Yeah, no, that's promising. I don't know where are you going from here? Like, what are you working on over the next few years? Are you involved in the human on a chip work, or is that?
No, I mean I'm on the periphery of that. One of the things I did do a fair bit of work on is one of the things we run into is all we had in the past is mouse data or rat data, and we extrapolated from there to humans, and we sort of had this black box. You use 50 rats and you have effects, and then you assume that the rat is this size and the human is that size, so you should see the same effect in humans at a lower dose, calculate a safe dose. And all those things assume that when you get a test result, it's actually the right result. And, so by saying, for instance, let me rephrase that a little bit. You get a test result that says your effect takes place at 3 milligram per kilogram body weight. Pick a number, but that happens to be an easy one to work with. And what that really means in real life, when you repeat the experiment, it's not going to be 3. It's going to be somewhere between 1 and 10. So there are all these uncertainties that are in the old methodologies, and they kind of cascade. One method has a 10-fold error, another method has a 10-fold error. By the time you add them up, you could have anywhere up to a 100-fold error, and so on. And one of the things you're going to run into is now that you have all these wonderful test tube methods, people are going to say, well, they're not repeatable because they have variability. Well, what people forget to go back to is to the animal experiments and say we have even worse variability in the animal experiments than we have in the test tube. So that's something that quite a few scientists, not myself, doing the actual research, although I've described some of the data in the data analytics and said, look at this data, that's how variable it is, and don't say the toxicity of something is 5. You have to sort of say that if it's 5, it's probably somewhere between 0.5 and 50 is, more of a realistic estimate.
Wow.
But don't be surprised if when you repeat an experiment that says 5, it comes out with 12. No, it's not a wrong experiment. It's just the experiment that's done in a small number of animals, and things are variable.
Well, how is anyone supposed to really test the efficacy and health effects of a given chemical or chemicals?
That's the question that everybody's struggling with. And one of the things is that in the past, people have just assumed if you did one test and you got one number, then in real life, what happened is you throw a safety factor on it of, pick one, 100, and that's safe enough for human use. And what people are realizing is that that number isn't real. And what we need to do, instead of just throwing on safety factors for the sake of safety factors, we actually have to sit down and for every step determine what the uncertainty really is, and then multiply that out and say, oh, if I have a test tube effect of, again, we'll go back to 3, is the total factor that we need 100, 300, 30, and actually do the math rather than just picking a number out of the air, which is what happens most of the time up till now.
Are there any chemicals out there right now that you consider to be, highly dangerous and in need of more regulation, or, to be taken off the market?
There are some chemicals that aren't great and they need to be taken off the market. The problem is that everything they've come up with so far for replacements is not much better. So the answer again is, using green chemistry, can we come up with something that does the same thing? Mostly they're solvents that does the same job as the solvent, but doesn't have the same toxicity. And that's something, we're talking chemicals that are, in the 100 millions of pounds. So trying to come up with a commercial process that replaces all the uses that it has throughout the entire economy would be, it's a major job. It's not something that's going to happen overnight.
Yeah. It's a very complicated picture. I didn't realize all these factors were in play.
Yeah, I think, again, it's, you both need to, it's science. It's not something that, every time you do a scientific experiment, you end up with the same number. There is some variability, sometimes it's small, like when you measure, even when you measure, say, the diameter of a quarter, it's not exactly the same every time. It's got a little bit of variability, not a whole lot, okay? But it's not like they're all exactly the same. They have a slightly smaller, bigger difference. And, when you use a coin machine, you have to account for the fact that sometimes they're a hair heavier, sometimes a hair lighter. And you're talking small percentages. But everybody needs to be used to the same thing as your speedometer. When you're driving along at 60 miles an hour, are you actually doing 60, even though your speedometer says 60? It could be anywhere between 58 and 62, that sort of thing. So people don't think about uncertainty in their lives because, when it's a number, it's a number. They never think about the fact that that number may just be an approximation. And as scientists, we don't do a good job of explaining that hard numbers really don't exist. They're estimations and have their own uncertainty all the time.
So do you have like a picture of Werner Heisenberg in your house?
No, the colleague many moons ago made some sort of comment about the study of epidemiology, which is where you look at large populations and try to find effects. And, one of the things there is there's a whole bunch of ways of doing the study, but the problem that always occurs is you either find the exposure perfectly and you have problems with the effects, or vice versa. You have rather lousy exposure data, but you find lots of effects, and then you have to correlate the two. And you always had a large uncertainty there of whether, an effect is correlated with the exposure in real life, or whether it's just one of the statistical anomalies that just pops up once in a while.
Right. Yeah, I didn't realize this is so complicated, this analyses.
Yeah, I know. I mean, it's presented as a single number. Drinking water levels shall be below 2. But, nobody sits down and actually goes through it and critically thinks about it and, takes it from there. And I guess, as I said way before, is communicating that sort of thing to the public is, difficult, but it has to be done.
Yeah, that makes sense. Well, very good, Hans. How can people find out more about your work? Where can they go?
You can Google me. My website will come up, Safer Chemical Analytics LLC. You can Google me and find some of the papers I've published and read those. They're not very general public friendly. There is a Reddit out there that I did for the American Chemical Society a couple of years ago on toxicology, which makes an interesting read. It's long, but there are a lot of questions and answers in there too.
And your last name is probably the easiest way to identify it. So it's Plugge.
There is one other Hans that publishes, but there's only 2 of us. And he's in a completely different field, so it would be pretty easy to tease it out.
Oh, good. No cross-contamination there.
No cross-contamination. So it's not like you call John somebody and, there's 16 Johns out there and you got to figure out what's going on.
Yeah. Well, very good, Hans. Thanks so much for coming on the podcast and explaining all this. I really appreciate it.
Thank you for having me.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.